So with objects, like I was saying, I'm just going to repeat it for the recording, is that we do have different elements that belong to an object. The name, the members, which is a series of attributes that an object might have, constructor, which is a way that we're creating the object, and methods, which provide a mechanism for us to manipulate the object. Let's get some numbers, but let me add, first of all, a separator. Okay, let's get some numbers. So far we are understanding that. So because the members are essentially things that the object holds, and let's just erase this, attributes, basically anything that goes into a variable can go into an object member. It could be, if we think of the object very big, like this, let's assume that this is our appointment manager. And in an appointment manager, we have a string for the client name. And we have a string email. And then we also have a calendar entry for appointments. Also, you might have a long for, I don't know, the amount of dates, or the amount of nights after that you're going to stay at that place after appointments. So let's say total stay or total, yeah. You can see that we were able to mix object with primitive. It doesn't matter what the object holds. Like, you can build complex structures that way. Let's continue with this. So now that we understand all the elements of a class, then let's go into the constructor. The constructor allows us to define how we're going to create the object. And such creation, sometimes you can just not have anything, just create your object. And the other one is when you pass arguments. So what are the elements of a constructor? You have the accessibility, which is public, protected, or private, like class, package, sub package, and world. And we'll understand a lot of those in a little bit. Protected, which is a little bit more restricted. The world doesn't have access. It's just class, package, and sub class. And then private, we have class, just that class. So from that perspective, then we can say that we do have essentially public. If this was a social media profile and you made your post public, that essentially means that everybody in the world can actually see it without restrictions. Protected, that might mean that only your friends, a group of friends, is able to see it. And then if we go into private, only me, or only that class. A good example of something that is private information is your bank account. Your bank account, you would not be sharing it with other people. Protected, essentially, could be your house. You could invite friends over and they can come in. And public is just like going to the park. Those are the three aspects that the accessor keyword covers. So we have public. These, then we have like I want to call it like a description, but it's just the name of the class. Let's just leave it simple for now. Where essentially we're just giving it a name of the class. And these has to be same for file name and also for class name. So if you have a typo in the constructor, it will not compile. And obviously, between parentheses, you get whatever arguments that are sent to the constructor so that you can start utilizing it in case that you need any. Let me get some numbers here. Okay, so as far as methods are just those things that we have called convenience functions in some of those objects. What do? They just provide mechanisms for doing something that we don't want to do that often or as often as possible. So developers of the Java API have developed hundreds of methods to a specification just so that you don't have to. You can combine them by calling them, and the way to call them would be by utilizing a dot right after the variable of the object or the name of the object that you have created and assigned. Same thing as the accessors. We have the public, protected, or private methods. The only difference between the constructor and this is that we have a return type, and that return type is expecting to return that value to the class that called it, utilizing that data type. So if we are saying that we are passing a Boolean, these better return a Boolean. They do match these two guys really well. Okay, so now that we understand that, then the method is the thing that precedes the variable type, and then in between parentheses, what we are actually getting as an argument. Doesn't matter the data type, you can convert anything to anything. It's just as long as the return type matches the promise that the signature made, that's preferable. And that's more secure. Okay, so how does this translate then to our examples? So if we grab this Lego blueprint, and I try to make sure that, or at least abstract it to the point that it's somewhat similar to our Lego man. I have created a Lego man that has the shirt color, the arm color, the pants color. Basically, those are the three main characteristics of a Lego guy. And technically, if you take them apart, you are not instantiating them, or you're going to have to recreate them. In this particular case, we have two constructors. You can have more than one constructor. There's a default constructor that has the parentheses. And then you have a constructor that is receiving three strings, one for shirt color, the other one for pants color, and the other one for arms color. And once you receive those, then you're essentially storing those values into these variables. So these dot pants color essentially refers to this one here. These dot search shirt color is essentially this one, and pants color is this one.
I have a quick question about
Yeah.
this. So in C#, we do something like, for example, arm color equals arm color, but the variable arm color on the left would start with big A, and we'll just switch one letter. Is something like that doable in Java, or is there a specific reason they have the same names besides this, of course, at the start?
Not sure I understood the question. Could you probably rephrase it?
So for example, here we have this dot arm color equals arm color.
Yeah.
Both arm colors are identical. Is it possible to do something like arm color with big A letter at start equals arm color?
Yeah. As long as those values are different, then you're telling the compiler use this one instead. Yeah, if you use uppercase or lowercase, and then the other one is lowercase, it doesn't necessarily matter. Essentially, what is here in this mechanism, this shirt color is the name of the variable that you're going to pass. So essentially saying, oh, shirt color. I had to use this mechanism. Like if we had named these differently, I could just say pants color equals pants color or pants color 1. Shirt color equals shirt color 1, and arm color equals arm color 1. The mapping from these values to these values.
So you said there's two ways to do constructors, right? the first block that you have here with these equals blue equals white, that's synonymous with the next block, meaning that you only would need one of those two.
Of these, I mean, if in this constructor we had only two elements, then we could use that. In this particular constructor, we have to use the three.
So is the third block of code, is that basically connecting the first block to the second block?
No, that's independent. What that second constructor is allowing us to create it with blue, white, and white, because those are the defaults. It's picking up the defaults and essentially populating them that way. We're just telling the computer it's okay if also you don't get any arguments. We'll go with the defaults. If you want to override the defaults, you have to pass the colors in this particular example. Actually, it's really evident here where we have two Lego mans that we created from the same class. We have Lego man LM1 equals new Lego man, and everything is in between parentheses. So because the defaults are white and blue, he is now essentially dressed as a Walmart employee. I had not thought about it that way until now.
I have a question. If you go back one slide, how does it know to assign blue, white, and white?
Oh, yeah.
Because those are the defaults.
Okay. So what happened? Can you so it's just like a null constructor. There's not you're not passing anything to it, but
Right.
it knows to pull from those fields.
Yes. Because you're not, those fields it's not like it's doing anything magic. It's just like when nothing is defined, it's going for whatever the default. And if you're setting the default, those values, and it's going to do that. But
I guess
sorry.
I guess I'm just confused because I don't know. I don't know what other languages I'm thinking of, but like when you're defining the constructor, I guess as the parameters, you can like set it as a default value, right? Like if you go back one slide for like say for the first constructor, can't you just set like so like in the parentheses, can't you just do like string shirt color equals blue, and that'll be the default?
Yeah, I could do it on the second constructor as well. Yeah. Just another way, like I could have a constructor of one element and then the other two would be in the same thing.
I guess I was just confused on like how it knows those fields are the defaults, I guess.
Yeah, and this is actually just as soon as a class is created, they were created with these values, and this guy is not modifying it. This object was creating it created with these objects, but if we call it with this constructor, overriding those. Let's get some numbers. Do you guys notice that it also became yellow on your end, or is it just on mine?
Sorry, what's yellow?
What do you mean yellow?
All these, or is it perfect white? Never mind. So this class here, and actually here's what I would like you to do, because this is the part where I really gotta take you. Well, let me just switch it to set this up, and we're gonna set this up here. And we're going to create, I'd like to create a class square. I would like you guys to try to copy this. And for that, let's just set up a timer. Let me. 3 minutes. Okay, copy these. I would like you guys to copy that class, that code, please. Okay. So I copied this, and I'm assuming that because I gave you 3 minutes of extra head time, you guys copied it as well. Why did I ask you to copy when you could have just simply copy and pasted? Because I want you to be familiar with this class. Why? Because this class is actually going to teach you a lot about object-oriented or classes in general. Okay? So a couple pointers here. We have one constructor, 2 arguments separated by a comma. You can see how multiple arguments are separated by a comma. All of our parameters, you know, even though that they are double, they do have a relevant name of the variable of what we're passing. So for example, this my width is essentially saying what is the width that we're passing. This one has the keyword factor. That means that when we scale the width, we're going to scale the width by whatever factor that we want to. And rotate, we're going to pass something that is representing an angle, even though that it's a double. So far, so good? Yeah. Okay. So, like I said on the slide, let's just trust this math. And when this code happens, square first equals new square. That's a you know, like if we created a class 5 object, also new, say class 5, and we create the main method. In that main method we can do square first equals new square. We can pass 1, 1. You can notice that is saying X pose and Y pose as labels, even though that it's not part of the code. Like if I copy and paste it somewhere else, it's just these parts of the code exist, not the X pose and Y pose. But IntelliJ is being smart enough to know that it's called X pose and Y position. Why? Because it's named like this in the rest of the code. So far, so good with that? Yeah. Let's do some numbers all the way for that part. What happens when we call that code? What does it happen? Well, what happens is that it is calling the constructor, which we know from this, that this is our constructor. And because we pass a 1 and a 1, and because this one is a double, and double is converting from this to a double automatically by adding 0. So essentially, the constructor becomes public square 1.0, 1.0. And then it says this point X, which is what we have here, this line, will be whatever we pass, which is that 1.0. And then this point Y, it's the same thing, but with the other one, and it's 1.0. So once we call an object and we create an object that it's on the position 1 and 1, this is representing what it just happened in the computer. We created that object. So X pose and Y pose are required, and width is not optional. Yeah, that's just my design, honestly. I could have actually made this also like require double width, and you know that could have been also evaluated. But right now I'm just saying like the width is of a default unit value of 1. It basically then created a square at a position 1, 1. So this line of code created a square of a position 1, 1. Then what happens if we scale the square? If we were going to call that first dot scale, which essentially, if I go back to my class 5 object here, and I say first, because it's the object that I have created, first dot scale, and then I do 4.0, it's going to call the scale function, which we have in here, is essentially calling this line. This single line is calling this on the instance. And it's going to translate the code that we have. So we have that the width, because it was 1.0 and it's receiving 4.0, it translates into this last part. That's what it's happening inside. It's translating and assigning to that particular instance a value of 4.0. In other words, let me just switch to my QuickTime. In other words, when we create, if we created that first object, and I'm going to represent it now like this, where we have an X of 1 y of 1 and a width. Initially, we had a 1, but then we said scale it. So then now that is triggering this value to be 4. This is our first object. Good thing that I see the knots. Honestly, like the knots help me a lot. So let's do numbers. We feel pretty good about our first object. Then when we scale it, we essentially are representing that, 1, 2, 3, 4, a 4x4 scalation on our square. Then if our code, so we did this first dot scale. So if our code did this, square second, we're creating a second square equals new square. And then we say 1, 1, same thing. It is essentially translating to the constructor as well with that we're familiar with, which is this guy. And then it's substituting all the values for execution. So then it says, okay, I'm passing a 1.0, a 1.0, perfect. And now I have created a square of 1 and 1. And you see here, both of these are alive now. Essentially, the first square is 4 blocks and the second square is 1 block wide. I'm gonna leave you 2 minutes or 3 minutes, since that's what I have, to copy all these parts, then just to make sure that we're up to date. Okay, so now that we are, why is it not? Oh, yeah. So now that we have created the second one, if we wanted to rotate the second square by 45 degrees, what would be the code that I need to add here? Who can tell me? The what? Sorry?
Second dot rotate.
Okay. Second dot rotate. Okay. And by what would be the angle?
45, right?
Yeah, exactly. So now you see the code, essentially how it's rotating the second square 45 degrees.
Oh, I think
Would we have to put in a decimal point because it's double?
Remember that casting can auto cast by adding the 0.0. So it's not mandatory. It's ideal, yes, but not mandatory, because it is converting it from an int to a double by adding the 0. Then actually, you know what? I think I may go into an earlier rest, because I want to come back to this one that is a little bit more involved. So then let me pause this guy. Let's just do a slightly earlier rest than the other times, just essentially by a few minutes. But I do want to go and cover this one without having to interrupt the cycle. Before we do that, let me get some numbers of overall classes, methods, return types, everything that we've seen so far up to the square and rotation of that square. And before we went to the break, we made a class that has a width and a position in X and Y. And that width essentially is representing both things as height and width, basically, because a square is a shape that has the same length and width, correct? We all agree on that, right? Yeah. Okay, so now that we have this square, what if we wanted to use it as a rectangle? And what's the difference between a square and a rectangle? Who can tell me? Let me ask Brandon. Brandon would know. Oh, Sareth, actually, yeah. So a square has 2 even sides, a rectangle doesn't. Correct. Sareth, thank you. Yeah, exactly. So then what we're going to do is that we're going to modify the square to be like this one, essentially. Why am I doing this? because I want to be able to reuse code. And the number one rule in programming is to not repeat yourself. So what I'm going to do is that I'm going to right click here and I'm going to do refactor, and I'm going to rename, and I'm going to change it to rectangle. And once I did that refactor of the class, it also renamed the file and it changed all the references, including references elsewhere in the project. So that's kind of cool using the refactor tool, right? Okay. Let me make sure that we are both, all of us, in sync here. So maybe just either nod or type okay or something. So when you guys have refactored your class. Let's see. Brandon, Josh, Jose are ready. Leon, have you been able to refactor?
Yeah.
Okay. Sareth, have you been able to refactor? Okay. So everybody has refactored. Okay. So then we are going to just add double height equals 1. So I'm going to put this in here, another line. And because we have the height and the width, I'm going to copy this method and paste it right below. And I'm going to change any reference in that copied method to height, my height, and my height. And here I'm going to change it to height. So now I have copied, I have added the height by adding this. So when you have added the member height and the method set height, just type OK on the chat. Okay, so I got confirmation from Brandon, from Sareth. Okay, everybody has at this point. Okay, cool. Now the next step is to, on the scale, we're also going to add this dot height equals this dot height times factor. And at this point, we have changed completely the square class to a rectangle class, where we have varying differences between the height and the width. Okay. Let me give 20 seconds more so that in case that anybody's double checking things. Perfect. So now, then let's continue. Let's move on. When this code happens, this is very much, this is pretty much what we were doing on the first rectangle, yada, 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 yada. It's the same thing. Like if we did this first rectangle and, the same thing calls the constructor that we're familiar with, replaces that, and we have a rectangle that has the same width and height because that's the default, right? So it looks the same as the square because we haven't altered that. So far, everybody so good? Everybody good? Unmute yourself if you're not. So if we go and we say first dot set height, now something very different than with the square happens. We're only affecting the height, effectively saying that it's a 4x1, well, a 1x4 rectangle. And again, first set height replaces the set height double my height, and it just uses 4.0 because that's what we're calling it. Then it replaces that in the wherever there's my height and executes that, and ta-da! Now we have a 4 height. Then, if we want to have a square, and let me just essentially stay back here. So quoting Sereth, what is the difference then between a rectangle and a square if we want to have a square again?
Make the width 4.
Exactly. Make the width 4. So what we gotta do for the square is that we are going then. What basically Josh is saying is that you need to keep both the width and the height at the same value if you want to have a square. So we want to have a rectangle, but also if we want to implement the square needs to make sure that both the height and the width are implemented, are scaling or changing every time that the value changes. In other words, let me do this. We're going to right click, create a new Java class, and we're going to call it square. We're keeping the rectangle as is, but what we're going to do is that we're going to use a new keyword called extends. And we're going to say extends rectangle. Now I'm going to hide this guy because it's giving me a red line. And when there's a red line in here and in here, something happened. So I'm going to click on this icon and it's going to say create constructor matching super. We're going to just follow that recommendation because that's what we've been told so far. Right now, let's just trust in that. So when you guys have gotten to this point, type OK. Okay. So now the thing that we got to do, Josh already pointed it out. We need to make sure that if we change the height, we are also modifying the width. And if we're modifying the width, we're changing the height. So, so if in that particular case, then we're going to override the void set height double my height. And then we're gonna apply the same thing to both. So this dot width equals my height, and this dot height equals my height. With this, we are constraining the square or the shape to be square. And then we're gonna duplicate it and do the same thing for set width. And with this, doesn't matter what we're doing, what we're changing, we're guaranteeing that a square will be a square. But we didn't have to rewrite everything from scratch because the extends keyword is essentially giving us a template from where to start. It's essentially saying we're going to inherit, and we're going to talk about inheritance more in our next class. But basically what the compiler is doing is that it looks, oh, this class square, okay, extends rectangle. Let me look at the source of a rectangle. Okay, I got the source of rectangle. Let me put it here. Oh, you got the constructor. Okay, let's replace the old constructor with a new constructor. Oh, you have a new set height. Well, let's put it in there. Does it exist? Yes, let's replace it. Same thing with with set width. Actually, before we do that, anything, is everybody caught up? Is somebody not caught up with implementing these methods?
So is that something like this or no?
You can, yeah, you can override it by using something like this. But the compiler is smart enough. The compiler is smart enough that, you know, in this particular case, it will not require it. That's something that we review in Java 3 mostly, I think. So I'm like right now, it's not necessary for this particular exercise, but I'm glad that you asked it.
So extends basically deals with all of that overriding.
Okay.
Yes. Then let's get some numbers for this part here that we've done with the rectangle and the square. All right. So so far we've only used methods that have the void keyword, and because of that void keyword, we don't need to return any data. But when we're utilizing anything other than void, it is necessary that we return a value. Basically, when it's void, the compiler automatically is adding this. We don't see it because it's unnecessary, but it's basically that, just saying return. There's nothing to return, so you know it's not needed. But what happens, for example, if we were going to, and let's go back to the to the rectangle because we can, if we add it to the rectangle, we add it to both. So we do public double get area, and the area of a rectangle is the base times the height. So the width times height. That's the area of our rectangle. You can see that it is requiring me, like if I just did this, you're gonna see that it's in red, right? There's all these red stuff that obviously says remove expression. And if I remove that expression, it's gonna complain. And if I try to compile it, let's go into class 5, which is where we have our code. It's saying missing return statement on rectangle Java, line 32, column 5. This is important. Line 32, you can see that this is line 32 right here. And then column 5. So it's 1, 2, 3, 4, 5. That's column 5, where this character is. So it's expecting a return value. And that return value, like I cannot just return a return false, because if I try to run it that way again, it's going to say that it's incompatible. Boolean cannot be converted to double, because we are promising a double value, but we're returning a Boolean. We cannot return a string because it's going to say string cannot be converted to double. We have to return a double. Therefore, an operation in both of these guys, again, recap, summarizing, return is necessary when you're not using void as a data type. Essentially, that these in the functions, the first thing tells you the availability, how hidden it is, or what's, if it's public, private, protected, etc. The second argument is telling, or the second thing is telling you the data type that you are promising to return the data with. The third item is telling you the name of the function. And then between the parentheses is all the arguments. And then between the curly brackets is a function. So when you're using void and the return type, you have to return nothing. You don't have to return anything. But if you use anything else other than void, you have to return a value.
In the C class that I was in previously, what's in the parentheses, they called a parameter. You're calling both the thing that when you call the function in those parentheses and in the parentheses in the function itself, an argument. Is there a difference in Java?
Yeah, so I'm calling this ones the either arguments or parameters is the same thing.
Okay.
Yeah, none of these are parameters, and if I misspoke, I apologize. It shouldn't have, but no, these are not arguments. These are arguments / parameters.
Okay.
There's many ways to call different things. Like some people call, for example, these guys up here, instance variables. In some other cases, they're called members. Some other people call them attributes. So it's just, it's like saying dog and canine. There's many ways to call them. Okay, so that's where we left it at that. Okay, this is something now interesting that an exercise that we're gonna go through. But before we go into that, just want to make sure that the return, the method and the return type are understood. Let's just get some numbers of that part, please. Okay, so now that we have everything here, let's talk about the singleton. And let me then go back to our trusty whiteboard. So a singleton is a pattern from this book, actually. Well, it's a pattern in general, but there's this book that it's called Design Patterns. Let me just make this bigger. software design pattern. Oh, now it's using some other thing. Django 4. This is a book. This is a book that it's literally a classic. And the design patterns is essentially a book. It includes like C++ examples, but it is essentially like a cookbook or a, let's call it, if this was cooking, this is a book of wine pairings, if you want to think it that way. What goes well with what, and the Singleton has different. I mean, this design patterns book has different patterns to follow depending on the problem that you're trying to solve. One of it has the creational patterns, the structural patterns, and the behavioral patterns. Basically, creational is how do we create instances. Structural is how do we organize things or components. And the behavioral is how do those components interact with each other. So one of the patterns that I'm going to teach you today from this creational pattern, or how we create stuff, there are some that, it's really funny because this book was published when? It was 1994. Okay, so it's not as old as I thought it would be. But this book essentially has described so many patterns that are still seen today. Like Singleton, we're going to learn it right now. Prototype is how JavaScript ES5 you create objects. Factory method is a method where you want to control how an object is created by a factory, by a class that it's external. We're going to follow a little bit of that pattern in the Singleton. A builder is a builder. If we went into, like, say, and I just want to go into, whatever website. The builder method is when you go through some process like this, where you click custom order, and then you are essentially passing all the different parameters to select and build your object before you actually build it. So you are co-creating the object concurrently by just going one argument after another argument after another argument. We're not gonna stay in detail there, but just that's a builder pattern. And the other one is an abstract factory. Right now, I'm not gonna worry about that one. I'm gonna stay within the Singleton. So what is a Singleton? The Singleton class is a class where you have it's a class to make sure that you create one instance only of that object. If you guys remember with our Lego man, we could have created many of those Lego man, as many as we needed. Each one of these, when we call new Lego man, just like we did with the square, new Lego man. And for this one, new Lego man. In all these guys, it essentially created a new instance. And just to, explain the instances in a bit of a better way, let's say that this is Josh, this is Brandon, and this is Leon, right? And I'm just, sorry if I didn't mention your name. I'm just going to whatever is appearing on my chat room from the top to bottom. Obviously, Josh is a very different instance than Brandon, right? Like two different people. Each one of you is a distance of it's an instance of the class human. So whatever happens to Josh, if Josh decides to get a haircut that gives him a mohawk, let's put it as a mohawk in red. He gets a red mohawk. Okay, Josh gets a red mohawk. That doesn't mean that Brandon is going to have a red mohawk. Maybe Brandon decides to go for a David Bowie, you know, the David Bowie makeup, and only Brandon gets that David Bowie Ziggy Stardust makeup. And Leon decides to get sunglasses, and he's the only cool guy with sunglasses, you know. Different things happen. So each instance has its own values, and each instance is created differently, and each instance, what happens to one instance doesn't necessarily will happen to the other instance. Yes, there are methods that are similar. So this is the traditional object creation. And of course, if we look at our memory, let's assume that each cell is enough to store one of the new Lego people. You know, Josh would live here, Brandon would live here, and Leon would live here. And we have 3 active instances in our code. I feel like I have to include Jose. He's just so focused and so intense with his look right now that I got to include him. So I'll create a new one on the next one. So fortunately, Jose is you know, Jose, are you a single child? No? Okay, who's a single child here?
I am.
Okay, well, Leon, sorry, I'm gonna take you from the sunglasses. I'm giving those sunglasses to Jose. It has a guarantee that one and only one instance will be created. And I'm using as an example Leon here because Leon is a single child. So when you have that guarantee that only one instance is going to be created, and it doesn't matter how many times you call the name Leon, you're always going to get our Leon here. Now, in what cases it is valid? Well, let's assume that we are talking about the US government, right? We're writing a software for the federal government. And in the federal government, there is a president of the United States, right? And there is Congress, where you have 435 members of Congress and 100 senators. And in the Supreme Court of the United States, we have 9 justices. It's pretty clear that because of these restrictions of numbers, let me circle it as well, that we need some sort of control creation mechanism. Where in here we're going to control that there's 9. In here we're going to control that there's 435, and in here we're going to control that it's 100 instances max. But let's just focus on the one that is the one that we are creating, making sure that there's only one precedent, right? So before we go to that point, there's another concept. So we understand that for the singleton exercise, we get a guarantee that we're only creating a single instance of that class. Okay? Now, before we go into that, I want to talk about one really bad keyword that Java, the developers of Java named it that way. It's called static. And we've seen that static in situations like public, static, void, main, right? Well, we usually have the string arguments. And we've seen that keyword static in that at that point. So what does the keyword static mean? So we have our blueprint. And let me change to a blue color so that it looks like a blueprint. So we have our blueprint where we are saying that, you know, our class has this height and this size, and it can move, and it can run, and it can laugh. This is our class that we're trying to create. Okay. And even to try to put it in terms that we were just discussing, that, for example, in the case of Josh, he had a mohawk. In the case of Brandon, he had a Ziggy Stardust, David Bowie style thing on his face, and Jose had some sunglasses. We understand that instance will have different values. So let's think about, you know, like if we were talking about, say, a bank account. Everybody here, I'm assuming, has a bank account. So in that bank account, what would be the attributes of a bank account that each one of the instances, you know, Jose's account, or let's actually switch numbers now, that names. We have Sareth, we have Sareth's account, and we have, well, I'm gonna start recycling. And Jose, just because he arrived late into the party, Leon. So let's just put Brandon's, well, let's just put these two accounts, Sareth and Jose. So Sareth has how much money in the bank? How much money do you would you like to have in my fake bank, Sareth? All right, Sareth has 600. And Jose, how much money would you like to have in my fake bank?
Maybe like $1 million.
$1 million. Just like Dr. Evil. $1 million. So, okay, so obviously the account of Sareth and Jose have different balances. And this is a member, is an instance member. Why? Because different instances have different values. However, there is another concept, you know, like also what other thing would be depending into the account, we would be the account number. Right? The account number is different from Sareth and Jose. But there is one element that is shared by both and all the members of Juan Carlos National Bank, right? One element that is shared by all the members of Juan Carlos National Bank, it is called the routing number. And what does the routing number, if I change the routing number in one account, I change it for all the accounts. So if I went and I change it here, essentially Sareth and Jose's routing number would change, but the balance and the account number would not change. So far, so good. Everybody following me? Yeah?
Yeah.
I see Josh nodding. Brandon, are you nodding or are you listening to music and your head banging? Leon, so far so good?
Yeah.
Okay, Jose, you're following me? Okay, Sareth? Yes, okay, good. All right, so you understand that because that these guys, instance members, change when you individually. And this guy changes collectively. If he changes for one, he changes for the other. These variable right here, let me change color, are known as static variables. That means that they do not live on the instance of the object, but they do live in the blueprint. So that's why if I change it for one, I change it for everyone. And those static variables, the key component is that they live in the class. Whereas these guys here live in the instance. So for you to have a balance, you have to create an instance. But for you to have a routing number, you can call it directly on the class. It's different memory spaces. Now, why does all these have to do with a singleton? Well, it all has to do with where things live. We're talking about an instance that we're going to guarantee a single instance being created, right? So I would like you guys to go into your project area and right click and create a new class called Singleton. And we're going to do this together, this one together, okay?
Juan,
Yes.
can you have a static member, I guess, variable in a non-static class?
A class is not necessarily static or non-static. A class is a class, is a blueprint. So it's just where you're choosing that variable is going to live. The variable is going to live in the class, or the variable is going to live on the actual instance object. Does that difference connect?
Can you repeat that one more time? I'm sorry.
If a variable or a method lives in a class, it will not need an instance to be created for you to be able to read that.
I guess my question is, like, can you have like fields that are not static?
Yes.
Like those fields, you would need to instantiate them to like, or you need to instantiate an object in order to access them. But
correct.
But it's also like you can't access the static member of that class.
No, you can. You can. Okay. And we're going to do both in 1 second. Let me go back then to the example of where did I leave this? Okay, so if I do this, Wells Fargo routing number, it's essentially already giving me the Wells Fargo routing number. I can access the number because the class, it lives in the class, in the Wells Fargo account class. Can I have a balance? Can I have an account number? No, until I go and open an account. When I open an account, I'm creating an instance of that account. Did that clarify the question?
Yeah, that does.
Okay, actually, give me some numbers, guys, please, before we move onto static versus instance members. Okay, George and Sareth, since you are technically below the threshold where I don't ask questions, what part is unclear?
So for me, the only question is, I think it connects with Brendan's question, is will the class automatically become static if there is at least one static variable?
No, the class doesn't become static or non-static. The class is a class. It may have elements that are static.
Okay, then what's the purpose of saying public static void if I can just not say static? What is it for?
To create an instance in order for us to access it.
So is there no static keyword for classes?
Yeah, you cannot put like a public static class. You cannot put that.
Oh.
It's just inside of the class, you can say int routing number. And then let's just copy the one from Wells Fargo.
There's no such thing as static class. Okay.
No, there's no such thing as static class.
Okay.
No.
Okay.
Like static class, we can do something like this, and then double amount or balance. Right? If I go into public static void main, this is static. Actually, let me just type it with a lazy way, main. This guy is static because I do not need an instance of the singleton method to be able to call that method. If you see when I right click, it says run singleton.main. It's referencing the class, not the instance. So I could actually technically do singleton S1 equals new singleton. And if I try to then to do S1.main, it's going to complain. Oh, I mean, that is running the main method because it can access it. But if I did, for example, routing number, oh well, it will actually pick it up. What I'm saying is S1 dot routing number. It's kind of like hidden from that because it's not part of the class. But you can do let me try to think about actually how to not make that confusing. In order for me to like say, yeah, actually this is a better way. I can do and say routing number, and if I right click and run this, I'm printing the class's routing number. But if I did balance, because it's not static, it's going to tell me that non-static variable balance cannot be referenced from static context. Essentially, you need an instance. So I could do, S1.balance. So I'm accessing this value with an instance because I need an instance for that to exist. That's the difference between static and instance content. Did that clarify both of you, Leon and George?
Yep. Yeah.
Yeah. I think I just need this kind of an example to see more clearly, to understand the definition. Yeah.
Why is it important? Because when we go and create the singleton, for example, we can do a private static instance. Singleton instance. So right now, essentially, inside of the object, we're keeping the pointer to the only live copy that we're going to have. And I'm actually going to rename it to underscore instance, so it's a little bit more. And to prevent others from calling the constructor, because we want to control, like right now as it is, I can go into my class 5 and I'm going to delete this for now and say singleton S1 equals new singleton, and then singleton S2 equals new singleton. And then I'm going to add a breakpoint here, and I'm going to then run a debugger. And what I'm actually, in the meantime, I'm going to split write the content so that way I can have the singleton code side by side with the code that we're writing. So you can see that it created 2 different instances. You can see it down here. It says singleton at 468 and singleton at 469. Those are the references that we are keeping to the pointer of where that singleton is. We have 2 different singletons. That's basically what we're saying. One that is on the location 468, another one that is in the location 469. There's 2 singletons. The unique identifier is different for both of them, right? Therefore, I could keep, creating more singletons. And right now I am failing at creating only one single instance because I'm creating so far 3 instances right now. If the goal is that we create one single instance, we need to prevent this method from being called. We need to prevent the constructor from being called. So then what we're going to do is that we're going to private singleton. We're going to make the default constructor private. We're not giving it access outside of that class to be able to create instances. We are closing the doors. Immediately, I got 3 related problems because these guys are not able to access the constructor. Okay, if they're not able to access the constructor, we now have a problem. I mean, we block that problem, but we're having a problem that we have no way of creating that single instance. So what we're going to do is that we are going to then open up one door. And that door will need to be a way that I do not need to have an instance to be able to call it. And if I do not need to have an instance on a method, what is a keyword that I should use?
Static.
Static. Get instance. Oh, but we need a return type. And what is the return type that we need to get return? If we're substituting the constructor for this, what's the data type that it should have?
A single.
Exactly. Oh, singleton. So now we have the singleton there. And right now it's complaining over here because we're not returning a singleton. What we're going to check is that if instance is null, because we're in the same class, we can say instance equals new singleton. That is like for the first time that we call it. And then we can do return instance. Now we're returning that instance. If it didn't exist, it creates it. And now we can call over here singleton dot get instance, and let's call it a few times, 2 and 3, and even a 4th time. And now let's debug. Now you can see 468, 468, 468, 468. Actually, let's remove this guy here because it's just adding bulk. But you can see that it's the same instance. Doesn't matter what we're calling. Now, if does this connect with you guys? Let's get some numbers, please.
One. So we can still do like S1 through S4. Like we can still instantiate all those. Is that the same thing as? Is that considered the same thing since it's just all pointing to the same object?
Yeah. Actually, technically, we can do S1 equals S2 like this, and it's Boolean S1 equals S2 to string. Now it's gonna. It's the exact same object because it's comparing the memory location. In the memory location, doesn't matter what it is.
Yeah. But is there like a way to stop or like just only allow you to instantiate once, or is this just the equivalent of doing that? Like I know it's the same thing, but like, is there a way to make it throw an error if you try to instantiate like S2?
No, well, we could. I mean, there could be ways where if you want to instantiate S2, but if the constructor or if this get instance thing is doing its thing, if it's doing its job, you know, it's you don't need to throw an error. Okay, so seems like everybody understood this correctly. I think either I'm getting better at explaining this or I don't know what, but we're moving fast. Or I'm just, or everybody's just telling me like, oh yeah, we understand this, but but in reality, no. Anyway, let's talk about then now another instance, something that will help us with instances. So this is another data structure. And as a data structure, if you guys remember, let me switch to the dashboard, to the whiteboard. So with an array and the array data structure for essentially having a list of items, right? And I'm going to clone this guy. Okay. We're gonna have two memory arrays, right? And do you guys remember the properties of an array? Who can remember the properties of an array?
It's like fixed length.
Yeah, it's got a fixed length.
Oh, sorry.
All items have to be of the same data type.
Mm-hmm. Oh, okay, let's,
Mutable.
Yeah, mutable. Mhm.
So then you said that it has a fixed length
First memory.
and all the what?
First memory space is 0.
Yeah. Well, basically the main thing is this, the fixed length. If we want to copy an array, we have to essentially allocate an array of the same size plus 1 and then go individually and copy the arrays. Like if we want to add one extra item, which makes it really inconvenient because we might have an array, say of five spots. Let's just say that everything in here, everything in red is part of our array. And then we have an array of 4 elements. And if we want to add one more element, we would have to essentially duplicate the array 1, 2, 3, and 4, and add one extra space. So we don't even have enough space out of that. Also, we would have another problem because all the memory needs to be next to each other, which is the other constraint. Right? If the memory is continuous, you could have areas that essentially, you have enough space here for like a 5-element array, but you not necessarily can use it because at some point somebody added something in between. So this could be the in-between value. And rather than going back in and adding a value here, you can't because the array by definition has such limitations. So you have to have all your elements in the array in place. It's much more complicated. So when you have this thing, right? Let's assume that this is your linked list. And for whatever reason, you had fragmented memory. And that fragmented memory has data from another program in different areas. The linked list allows you to say it's a data structure that has a pointer to the next element. So then you can essentially use a fragmented memory in order to increment things without having to copy everything. Now, what is the downside? That in the array, if you are at 0, like Josh was saying, that it starts at 0, and you say I want to access the 4th element, you just grab that memory reference and add 4, and then you're there. You can jump directly into values. In here, you have to actually traverse and do all the jumps in order for you to get to the element that you're looking for. So it's trade-offs. One thing's for others. So the data structure that we are learning right now, as opposed to the array, is called a linked list. And that linked list, basically, it has a value that is stored and a pointer that points to the next element. And that next element, if it's null, it's pointing to nothing. But if it's actually pointing to another element, it's going to point into another one similar of a linked list where it's storing another value and a pointer to next. And so on. Essentially, we can build a chain where we have something like Josh with a pointer to Brandon, with a pointer to George. George, I totally skipped you on the last exercise. It's just that I don't have enough space here. Sorry, George.
Sure, it's okay, no problem.
The what?
It's okay, no worries.
Yeah, sorry, George. Let's put you, George. And then, you know, we can have Leon with his cool sunglasses and Jose with also with his cool sunglasses and Sareth. So you can see, like, you can have, you know, a list where you guys are pointing, basically similar to like if you were pointing with your hand and at each other. You can build a little bit of a chain that way. So the way that we build a linked list, and actually I'm realizing that I'm not getting better at doing this because I'm actually gonna have to explain this a little bit faster than what I was hoping to. So I'm gonna go to the project here and I'm gonna right click and click linked or my linked list, because there's one that is already built in with Java. For the homework that you guys have to do, I'm not expecting you to use a built-in. I'm just trying to help you understand how a linked list works. And a linked list is pretty much instantiation of elements. So we're gonna call it my linked list. We're not even piggybacking to the one from Java. We're just creating a new element. So like we said, we have a string name. For example, if we're using the name for everybody's name, and my linked list next is the pointer where it's going next. And I'm gonna close this file here because I'm gonna create all the code from here. So technically I can do my linked list, my LL equals new my linked list. And because I am going to make it faster or easier for us, I'm going to do public my linked list, a constructor, and I'm going to receive a string name where I'm actually saying what is the name that we're going to receive. That way I'm forcing the name to exist. So this dot name equals name. See, like the default constructor doesn't work anymore because I do have a constructor now, and it is saying that it needs a string. So for here, following this, I'm gonna put George at the top because I gotta make it up for George. So I'm gonna show you. I'm gonna move Josh to the next item in line. So I'm gonna swap him. Josh, George. Okay, so we have George. And then if we say my ll.add, we want to add another element. We're going to create a method that it's going to add. We're saying that we're adding Brandon. Notice that this guy went red, meaning that we still haven't. It says cannot resolve method add in my linked list. So the solution is create method add in my linked list. So I clicked on that, and it's doing a private void add my linked list. Again, we're operating on this level. I'm pointing it on the QuickTime. We're operating here because that's we're calling it on the my linked list that add element. So we know that the next pointer points to the next element or null if it doesn't exist. So we can do while. We can make a copy of that pointer. My linked list, what do we call it? Pointer equals this. This keyword is a keyword that basically it points to itself on an instance. Just like if I point the finger to myself, I'm essentially calling it me. Me for me is different than me for George or me for Jose or etc. You know, like me for each one of us has a different value. This is the same thing. This is this pointer. When I say I'm gonna have a pointer that it's pointing at whatever this is pointing, or essentially it's pointing at itself. I'm going to then traverse such pointer until I don't have any value, until I go to the end. So while pointer different than null, we can say pointer equals, oh, sorry, what? While pointer dot next is different than null. At this point, we're making it till the end of the list. And once we're at the end of the list, if we were like this, you know, I'm going to create it in blue that as we are as a copy, we're saying George. And we're saying, okay, find as, you know, this is a goal. And this is our current. So at this point in our current, when we're creating, and we say add Brandon, it's essentially going to create a new element, give it the name Brandon, and then point the next item to it. Let's do some numbers so far for this part. Okay, perfect. Everybody's at 9. Okay. So we have at this point with this code right here on the add method, we have found where we need to add it. Then the question is that we need to add it. Then we're going to do my linked list I for item equals new my linked list, and we're going to call next name. We're going to call it the next name here. And then pointer dot next equals I. Essentially, we are doing what I just told you. If you follow the code with me, I'm going to erase all these and do it again. So we have my linked list equals George, and then we're saying George add Brandon. So then he is like, okay, find until the pointer of next it's pointing to nowhere, which is, you know, the next pointer right now, it's just essentially like that, not pointing at anything. And then once you find that spot, you're going to create a new instance, which is this line here with a name that you gave me, which is Brandon, you know, it's next name. And then we're going to point our next pointer to it. And that's what we have here. So now I could technically keep doing something like Josh. Leon, Jose, and Sarah. And I'm going to print after this so that I can add a breakpoint, and I'm going to debug so that you guys see how that chain was built. So we have my linked list, which has a name George. The next element in the pointer is Brandon. The next element in the pointer is Josh. The next element is Leon. And the next element is Jose. And let me close this thing here. And the next element is Sareth. And Sareth is pointing to null. Therefore, the next element that I would add, it would go at wherever Sareth is pointing to. Okie doke. In this particular situation, all these different instances, notice 68, 69, 71, 73, 75, 77, and different names for each one of those. So, given this implementation, which I do believe that in Canvas, let me just double check that, because I do believe in Canvas, I have the same starting point, probably different names. Class 5, yes, there's a linked list element. Oh no, hang on. They didn't copy. Oh, my linked list.java. Yeah, there it is. Use this as a basis of your homework. And it basically has the same code. So here's what let me just then stop here and make sure that this was not just a bunch of blah and you guys did understand what I was talking about. Do you guys understand what the linked list is doing here? this data structure.
So this is like a,
Was that a what?
so this is like a dynamic array.
Yeah, it's a dynamic array. Correct. Okay. So now that we understand then what's going on here, and given the numbers from earlier, here's what the assignment will help you do. And by the way, what I can tell you is that all the ingredients for the assignment are already in this code. All you have to do is to repurpose it and make sure that it works for other methods. What are the methods that I'm looking for? The methods that I'm looking for, oh, wait, it's here. The methods that I'm looking for is the methods that it's add string, it's add, we already have it. I would like to print all the elements of the linked list. I would like to find out how many items are on the linked list. I would like to remove an element of the linked list, and I'm going to explain the only thing that you don't know that it's not possible to do with the current code, but I'll explain to you and then you'll know how to do it. And then item at of an element. So item at, if I say it's similar to an array, if I say item at 2, then it will return that element similar to like the square brackets 2. In remove, let's assume we want to remove Brandon. I'm just going to remove Brandon for now. The easiest way to removing an element in a linked list is finding out the previous element of the element that you want to remove and grab the next pointer and essentially point it to the next pointer of the element that you're trying to remove. So essentially next dot next. Basically ptr dot next equals ptr dot next dot next. So essentially 2 elements ahead. That's what you want to point it out. I would like you to implement those in this class, and that's basically the assignment for next week. Any questions, comments, concerns?
Is it worth 10 points or 15? Because I can see in assignment success, it says 15, and then on top it says 10.
Okay, so this one is saying 10 points, but oh yeah, no, it's 10. It's whatever is here. Let me edit that. Yeah, no, this is, I don't know what that was why the rubric of that was okay. Yeah, it's 10 points. Let me then ask a question. Let's get some numbers about the linked list. Just maybe I can clarify anything before we move on into into one-on-ones, but I want to make sure that everybody has a good understanding of that dynamic array, if you want to call it that way. By the way, Python arrays or JavaScript arrays are this way as well. Like they are an implementation of a linked list. A slightly more different and more optimized version, but yes, it derives from that. Okay, I've got George, Josh, Sareth, and Jose. Leon and Brandon, I'm missing your numbers. I just want to make sure I got you covered.
Maybe I can have some question in the one-on-one session. So that we don't waste
time. Do you prefer to ask it now or on the one-on-ones?
Yeah, I just a little bit confused with the formal, not the linked list. It's the singleton things.
Okay, yeah, let's go through the singleton.
So yeah, I'm a little bit lost here. So I just wanted to, maybe you can reinstate that, what's the difference between the, the relationship between the instance, the statics, and the singleton?
This guy, you want to understand what is this instance?
Yeah, like the instance and the statics, I kind of look at the definition and understanding what they are, but what's the like relationship between the singleton and the instant and static? I didn't quite get that part. Yeah.
Yeah, so because we're guaranteeing that we're going to create one and one instance only, we're going to create and hold that instance in the class itself. Therefore, preventing anything from being created more than once. And because we are trying to access that static instance and verifying if it's not being created, then we create it. And if it has been created, then we return that value. We essentially are just ensuring we're using this as a support mechanism to ensure that we only create it once.
Okay. Oh, what's the case that created two? Like,
Well, sorry, you go ahead.
yeah. I'm just asking, like, we only create this once. Like, what's the scenario when we create something twice? Like,
Yeah, a scenario of control creation, if we want to like have a control, it would be this, where we have, 9 justices. And if we did that, we could create an array list, a singleton or static array list, and just populate that array with elements.
okay, so if we
That is
like, okay, so if we define the singleton, then it's just update this the one single, not like just creating a list or array. Is that correct?
Yeah. Yeah.
Okay. All right. Yeah. I think I got that idea.
Okie doke.
Thank you.
Yeah, no problem. All right, so if then given the numbers on the linked list, then I'm assuming that you guys are properly equipped. I'm going to stop the recording. And 1 second.